Section 11.3.7-T, a researcher with the Department of Education followed a cohort of students who graduated from high school in a certain year, monitoring the progress the students made toward completing a bachelor's degree. One aspect of his research was to determine whether students who first attended community college took longer to attain a bachelor's degree than those who immediately attended and remained at a four-year institution. The data in the table attached below summarizes the results of this study, and we're going to complete part A through E. So here we have our sample size, we have our sample mean, and we have our sample standard deviation for the community college transfer and no transfer. For part A, it says, what is the response variable in this study, and what is the explanatory variable in this study? Well, recall the definitions. The response variable is a quantitative or qualitative variable that represents the variable of interest. The explanatory variable is the factor that influences the response variable. The variable interest in a study is the length of time to graduate with a bachelor's degree. The explanatory variable is the variable the researcher attempts to show is the cause of difference in the response variable. So the explanatory variable is the use of community college or not, because the researcher is attempting to see if this causes a difference in time to graduate. Okay, next question states, explain why this study can be analyzed using inference of two sample means. Determine what qualifications are met to perform the hypothesis test about the difference between two means. Okay, well, the difference between two population means with unknown population standard deviations approximately follows the student's T's distribution of the following assumptions are met. If the following assumptions are met, Okay. First is that the samples must be obtained using simple random sampling. The samples must be independent, the population must be normally distributed, or the sample sizes must be large, both greater than or equal to 30. The sample sizes are not more than 5% of the population. So, it is reasonable to assume the samples are random because it is reasonable to assume a researcher with the Department of Education would follow proper sampling gathering procedures. The samples are independent because any group of students who attend a community college is independent of any group of students who did not attend community college. The population is not given to be normally distributed, though the population is not stated to be normally distributed. The test can still be performed if the sample sizes are larger, both greater than or equal to 30. What is the smallest sample size? Well, the smallest sample size is 281 students. So the sample sizes are large enough, both greater than or equal to 30. So the sample sizes are less than 5% of the population because these sample sizes are much smaller than 5% of the total number of college students that either go to community college first or do not transfer. Therefore, we can say that this hypothesis test can be performed because the appropriate conditions are met. Part C. Does the evidence suggest that community college transfer students take longer to attain a bachelor's degree? And we're going to use an alpha equals 0.05 level of significance. Okay, so we know that the hypotheses are structured in one of three ways. We know it could be either less than, greater than, or not equal to. So let's first go ahead and discuss our null and our alternative hypothesis. Okay, so what is the claim? Well, it's saying here that a researcher in the Department of Education followed a cohort of students in high school during a certain year. And it says that one aspect of his research was to determine whether students who first attended community college took longer to obtain a bachelor's degree than those who immediately attended and remained at a four-year institution. So longer meaning than greater than. So we can say that the mean for the community college is going to be greater than the mean for no transfer. And therefore, the null would be the population mean of the community college would then equal the population mean of no transfer. Okay, step 2, this now tells us it's greater than, we know it's going to be a right tail test. Step 3, what is the significance level? The significance level is 0.05. Okay, now we need to determine the test statistic. So we have the formula for the test statistic, but what we need to do is bring down the information here. So this is our information that we want to be able to pull here. So we know that we have the sample size for mean 1, for population 1, which is a community college transfer, and then no transfer. So what we're going to do now is find the test statistic. So we know that mean 1 is going to be 5.29 minus mean 2, which is 4.29. And then that's going to be minus, well, if we have mean 1, which is equal to mean 2 in our scenario here, that means if we subtract mean 2 to both sides, then we know it's going to equal 0. So therefore, this is going to be minus 0. And then we're going to divide that by the square root of the sample standard deviation for the community college transfer, which is 1.121, square that. And then we're going to divide it by the sample size, which is 281, plus the standard deviation for no transfer, which is 1.005 squared, divided by the population for the sample size of no transfer, which is 1227. Okay, now let's determine what that test statistic is going to be. So using our calculator, in the numerator, we have 5.29 minus 4.29, which gives us 1. And then we're going to divide that by, we have second square root. We're going to put parentheses around the first group. So parentheses 1.121 squared. And then that's divided by 281 parentheses. And then plus left parentheses 1.005 squared. And then we're dividing that by 1227 parentheses. And then right arrow. And then select enter, and therefore now we're going to have our test statistic. Okay, so rounding that to 2 decimal places, we end up getting 13.74. Okay, so now what does that look like when we draw our bell curve distribution? Okay, well, we know that we have our bell curve. We know that we have a mean of 0. We know that our test statistic is going to be located here at 13.74. And we want to be able to find the p-value, which is the area to the right. So let's go ahead and find a p-value. Now the p-value we can use is the calculator function where we have TCDF, where our lower limit is 13.74 since we're finding the area to the right. So 13.74, and we know that we have 9999, which is the upper limit. Okay, now what are we going to use for the degrees of freedom? Well, we're going to use the smaller of the two population size, which is 281. That is the smaller of the two. And we're going to subtract 1 to get 280. Okay, now let's go ahead and do that. So we're going to take second distribution, scroll down to TCDF. We have 13.74, 9999. The degrees of freedom is going to be 280. And then we're going to select paste. And then that's going to give us our p-value. So let's go ahead and write down our p-value up here. Okay, so this means that we have 1.7 times 10 to the negative 33, because that's what it would be in scientific notation. Technically, if we move that negative 33 to the left of that decimal point, if we round it to 4 decimal places, we're going to end up with 0.0000. Okay, so that's going to be our p-value. Now, we can use the formula to find a p-value by using all this information, but because the p-value is going to be 0, we don't need to go that further on it. So we know that our p-value is going to be 0.0000. Okay, now let's go ahead and continue. Okay, so for part 6, okay, what we want to be able to do now is we want to be able to compare our p-value with our significance level. Okay, so remember that if the p-value is less than alpha, then we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. So let's compare the p-value with the significance level. So the p-value is 0.0000, and that is smaller than the significance level of 0.05. And since it's smaller than the significance level, then that means we are going to reject the null hypothesis. So therefore, we can now conclude the following. We can say we're going to reject the null hypothesis, and the evidence does suggest that the community college transfer students take longer to attain a bachelor's degree at the alpha equals 0.05 level of significance. Okay, now what we're going to do is we're now going to go ahead and construct a confidence interval. So let's go ahead and take a look at that question here. Okay, so for part D it says construct a 95% confidence interval where you have the population mean of the community college minus the population mean of no transfer to approximate the mean additional time it takes to complete a bachelor's degree if you begin in the community college. And remember that the bounds of a 1 minus alpha times 100% confidence interval about that can be found using the following formulas where the critical t-value is t alpha divided by 2. So here are the following formulas. We have our lower bound, we have our upper bound. Okay, so if we're going to do this by hand, we need to find the critical value for t. And we know that alpha is going to equal 1 minus the 0.95% or 95%, which is 0.95, which gives us 0.05. And then we know that alpha divided by 2 is going to be 0.05 divided by 2, which gives us 0.025. Now we need to look at the degrees of freedom. So if we use the degrees of freedom choosing the smaller of the two, we would use 281. So 281 minus 1 is going to give us 280. Okay. Now if we take a look at the t distribution, we have 0.025, okay, as our area. And then if you look here, we don't have a 280. But the closest one we would have to use is 100. So that means from here and all the way up gives us the area of 0.025. So if we're just going to use this one, we can use the critical value to be 1.984. But again, think about the fact that we're rounding down quite a bit. So we're using 1.984 to be our critical t-value. Okay, and then let's just copy down our sample size, sample mean information so we can plug that in to figure out what our numbers are going to look like. Okay, so if we want to find the lower bound, okay, we know that we have 5.29 minus 4.29 minus the critical value of 1.984 times standard deviation of 1.121 squared over the sample size of 281, and then plus 1.005 squared over the sample size of 1227. Okay, so let's go ahead and put that in our calculator just to find out what that's going to look like here real quick. So again, we're going to work within the square root. So we have 1.121 squared divided by 281 equals, and then plus 1.005 squared, and then divide that by 1227. Okay, and then we need to take the square root of that number. So second square root of second answer, hit enter, and now we're going to multiply that by negative 1.984. And then we're going to add, well, 5.29 minus 4.29 is 1. And so therefore, there is our result. So let's go ahead and take this value, and we're going to round that to 3 decimal places. So we're going to get 0.856. Okay. Now let's do the same thing for the upper bound. Okay, but the only thing that we're going to do now is we're going to add that number. So if we go back, we can go back up and find out what that answer was when you took the square root inside, which is there. And then we're going to multiply that by positive 1.984. And then what we're going to do is we're going to add 1. And so therefore it's going to give us that result. And so rounding that to 3 decimal places gives us 1.444. Okay, so here is our confidence interval. The confidence interval is the range from 0.856 to 1.444. Okay, now let's just go ahead and quickly do this on a calculator to see what it would look like if we would just use the testing function. So if we wanted to go to stat, and then go to tests, and then scroll all the way down to 2 sample t interval, okay, and then we're going to put in stats. We know that our mean is 5.29. We know that our standard deviation is 1.121, and then our sample size is 281, and then the mean is now 4.29 for the no transfer. Standard deviation is 1.005, and then the sample size is 1227. The confidence level is 0.95, pulled no, and then we're going to go ahead and calculate. Okay, so let's go ahead and take a look at that. Copy this correctly here. So when we use the TI calculator, okay, you're going to see that we get the degrees of freedom, which is different than what we used, right, to get the critical T value. But here we have 0.856, which is similar there, but it would be 0.857 because we would round that up, and then we get 1.43. So you can see here it's a little different again when you're using the calculator option. Let's also use Statcrunch. So let's use Statcrunch. So if I wanted to use Statcrunch, then I'm going to go to Stat, and then I'm going to go down to T-Stats, and I'm going to go to 2 samples, and I'm going to go to with summary since we've already gotten the summary. And so we know the sample mean is 5.29. We know the standard deviation is 1.121, and we know the sample size is 281. We know the sample mean is 4.29 for the second one. Standard deviation is 1.005, and the sample size is 1227. Okay, and we don't want to check the pool variances, but we want to check the confidence interval at 95%. So now we're just going to go ahead and select compute. Okay, and so let's select compute, and let's compare that with the calculator. Okay, so if you look at this value, okay, this gives us the same results as the calculator is. So the lower limit is 0.857, rounded to 3 decimal places, and also 1.143, which again is slightly different because of the critical value that we used. Okay, now in part E, it says, do the results of part C and D imply that the community colleges cause you to take extra time to earn a bachelor's degree? So recall that correlation does not imply causation, so the answer would be no.